Section 7.4 is the last section where you have to do another exponent rule. So the last exponent rule is what happens when I'm dividing. So when I'm dividing two powers, I am going with the same bases. I'm going to subtract those exponents. So you'll see here, if I have 2 to the 6th, if I have 2 to the 6th over 2 to the 2nd, my base stays the same as 2, and then I'm going to subtract those exponents. And the reason for that is because if I have 2 to the 6th, 2 to the 6th means that let me show you up here. 2 to the 6th means I literally have 6 2's. And if I'm dividing that by 2 to the 2nd, that means I literally have 2 of those 2's on the bottom. But when you're dividing, you're canceling things out. So if I cancel out a pair of 2's from the top and the bottom, you'll notice that I'm left with 4 2's on top and nothing on bottom except 1. So that's why I can just subtract the exponents and leave the base the same and get 2 to the 4th. Okay, exponent rules still apply here when I have negatives. So like in this middle example where you have x to the 4th over x to the 7th, I still subtract them and I get 4 minus 7, which is x to the negative 3rd. I need to make sure I still rewrite that so that it moves back to the bottom. Okay, let's take a look at a couple examples. So here's my first one, x to the 5 halves over x to the 2nd. My bases are the same, so I'm going to just subtract my exponents. So if I subtract 5 halves by minus 2, I'm going to get x to the 1 half. So then the next step over here, if I have m to the 2nd over m to the 5th and n to the 4th over n to the 3rd. Now, when you are subtracting, you want to make sure that you always go to the top. So when I subtracted 2 minus 5, I got m to the negative 3rd. And when I subtracted 4 minus 3, I got n to the 1st. Now I have to rewrite it so that my exponents become positive. So then my m to the negative 3rd would have to move back to the bottom in order for it to become a positive exponent. So then my final answer would be n over m to the 3rd. Now I want you to pause the video and try the last 5 on the bottom. So on the first one, you had y to the 3/4 over y to the 1 half. So you should be subtracting 3/4 and 1 half, and you would get y to the 1/4. On the next one, I have d to the 7 halves over d to the 3rd. Again, I have the same bases, so I'm going to subtract those exponents. So I would get d to the 1 half. On letter C, now I have 2, so I'm going to combine like terms. So my k's would be its own thing, and my j's would be its own thing. So I would do k and subtract 6 minus 1, and then I would need to do the j's and do 2 minus 5. So when I do that, I get k to the 5th, and I get j to the negative 3rd. Now I see that I have a negative exponent, so now I would change it into fraction form, and then I would need to move this j to the negative 3rd to the bottom of the fraction. So now it's going to say k to the 5th over j to the 3rd. Let's look at letter D. Again, I'm going to subtract my like terms. So I'm going to do a, and then I'm going to subtract negative 3 minus 5, and then I'm going to do my b, so then I'm going to subtract 7 and 2. So when I subtract negative 3 minus 5, that means that a is going to be negative 8. And when I subtract my b's, I get b to the 5th. Again, I have a negative exponent on this a, so that whole term is going to move to the bottom. So I'm going to get b to the 5th over a to the 8th. Okay, on the last one here, I see that I have x's, so I'm going to subtract my x's, 4 minus 4. I'm going to subtract my y's, so negative 1 minus negative 5, and I'm going to subtract my z's, and that's going to be 8 minus 1. Now notice this z on the bottom has a 1 there, so if you're not familiar, put that. So for my x's, I get x to the 0 power, so since I get x to the 0 power, I'm not going to write that at all. For my y's, I end up getting y to the 4th, and for my z's, I end up getting z to the 7th. They both have positive exponents, so I'm not going to do anything else with that. That would be my final answer. Okay, let's see what it would look like when I have an exponent on the outside with parentheses. So just like before, when you have an exponent on the outside of your parentheses, you need to distribute that exponent to everything on the inside. So for example, when I have 3/5 raised to the third power, I'm going to distribute that exponent of 3 to both of those. So it becomes 3 to the third and 5 to the third, and then simplifying those powers. Same thing here with my letters. I'm going to distribute that 5 to everything, so I have x to the 5th and y to the third. We've done this before, but it wasn't in terms of a fraction, so now it is. So let's take a look at this first example here. It wants you to simplify z to the 2/3 over 5, all raised to the third power. So I'm going to distribute this exponent to everything. So that means I'm going to do z to the 2/3, and I'm going to multiply that by 3. And then I'm going to have also that 5 raised to the third power as well. So on the first part, I would have z to the second after I multiplied those two, and then I would have my 5 to the third. I have more simplifying since I have this power, so the z to the second would stay the same, and then I would simplify the 5 cubed, which is 125. Alright, you pause the video and try the next one. So on the next one, I would need to distribute this exponent. So you would have 4 to the second on top, and then on bottom, I'm going to need to distribute to that x, so I'm going to end up multiplying the 3 and the 2. So I'm going to have 4 squared on top, and then I'm going to multiply on the bottom, so I get x to the 6th. I have more simplifying since I need to evaluate this power, so 4 squared I would change to 16, and then x to the 6th is going to stay on the bottom. Now, the challenging part with this is that they all step together. So there aren't any more exponent rules that we'll go through, but they'll all combine together. So let's take a look at this one. So notice on this one I have parentheses with an exponent on the outside. So the first thing I would do is go ahead and distribute this exponent of -3 to everything that's in there. So I would have 2 to the -3rd, and then for my x's you would have 6 times -3, and then for my y's you would need to multiply 4 times -3. So the first thing I would get when I multiply those, I would have 2 to the -3rd, x to the -18th, and y to the -12th. Remember, no negative exponents, and I simplify my powers. So I see negative exponents on everything, so it looks like all of these are going to move. The 2 will move to the bottom, the x will move to the bottom, and the y is going to move to the top. So everything's going to flip. So I'll end up getting y to the 12th over 2 cubed x to the 18th. Remember, no negative exponents, and I need to simplify my powers. So 2 cubed I would need to change to 8. Alright, pause the video and try the last question. So on
Devin Miller, please come to the office. Devin Miller, please come to the office.
On the last question, you're going to distribute that -2 to everything. So it's going to become a to the -2nd, 5 to the -2nd, and b to the -2nd. Notice everything has a negative exponent, so I'm going to have to flip everything. So the 5 will move to the top, the b squared will move to the top, and the a squared will move to the bottom. I can't have any powers, so I'm going to simplify that 5 squared and change it to 25, but the b squared will stay on top and the a squared will stay on bottom. So when you're running through these exponent rules, just double check and make sure, have I simplified all my powers, such as 5 squared changes to 25? Have I taken care of my negative exponents? And have you taken care of any exponents that are zeros?